This is Mr. Martin. These are the video notes for section 6.1. We're still talking about law of sines for pre-calculus honors. And in the last video we talked about the cases where you had two angles and a side. Any two angles and one side. The side could be included or it may not be included. And today we're going to talk about given two sides and a non-included angle. So if you remember from geometry, this was not one of our methods for proving that triangles were congruent, because if you're given two sides and a non-included angle, it's possible, depending on the information, that you could construct one single triangle, or it's possible that there's two triangles that you could construct, and it's also possible that there's no triangle that you can construct using it. So this first page of our notes here is a chart which outlines different conditions and the number of possible triangles with a picture to go with it. And to be honest, if you like this kind of thing and you want to memorize all this and figure out what it is, feel free to do that. But I don't do that because I think it's kind of a pain. But anyway, so if you want to go through and read through this chart and try and figure it out and determine whether you're going to have one triangle, two triangles, or no triangles, go ahead and do that. The one case that I want to take a look at here is this two triangle case, because for certain conditions what we're going to be given here are the lengths of sides A and B and then angle A over here. So you can see that there's two places where you can fit side A in here. We can fit it in over here to get this triangle, or we could fit it in over here. Okay, the side on the bottom really can be any length it has to be to complete the triangle to get this whole big blue colored triangle. So you can either get this skinny red triangle, which is kind of inside the other one, or you can get this big bluish triangle. And the last thing I want to point out before we go ahead and do some examples, I want us to look at this angle over here and this angle over here. Okay? This triangle here has A for both sides. These two sides are congruent, so this triangle is going to be isosceles. So this angle here is going to be congruent to this angle here. Those are the base angles of the isosceles triangle. And you can see that these two angles are going to be supplementary. So where this is going to come in, and I'll mention this again later when we get into some examples, is that this solid colored angle that I have marked is going to be supplementary to the angle that it sort of corresponds with if there's two triangles to that same angle. In this case it would be angle B in the other triangle, so keep that in mind. So go ahead and look through these as you see fit or want to. Again, in order to complete side-side angle problems without memorizing all these conditions, what we're going to do is assume that each problem is a two triangle case. Alright, and if it's not, as you work through the problem, you'll see whether it's a 1, a 2, or no solutions. So for the examples that we have, I've listed how many triangles they are, but you normally won't know. And I think it's always a good idea to just draw a sketch of a picture. And I tend to just draw the same generic triangle. So I've got triangle ABC, and then I label what I know. I know this side is 3, this side is 2, and angle A is 40. So when I go ahead and do that, I can see I've got two sides, and I've got an angle that's not in between them. The angle that's in between the two sides is angle C. That would be the included angle. So I've got my side-side angle case, and we know this is the one that we have to figure out how many triangles, if any, because it's a bad word spelled backwards, and we don't like bad words, so we don't like side-side angle problems. So just your little trick to try and remember. Now keep in mind we're going to do a whole bunch of side-side angle problems and you're going to practice a bunch, but you only need to determine how many triangles if it's a side-side angle case. All the other cases that we work with, it's just going to be a one triangle solution. Okay, so side-side angle, again we're going to assume that there are going to be two solutions. So what that means is that everything that's not given, there's a possibility of having two answers, one for each of the triangles. So there's going to be an angle B in the first triangle, an angle B in the second triangle, possibly. Actually, we know it's only going to be one, but we're going to pretend. And then angle C in the first triangle and angle C in the second triangle. Then we're given side A is 3, side B is 2. Again, everything that's not given, there's a possibility that there'll be two of them, so side C1 and side C2. So these are the things that we are going to attempt to find. Okay? Alright, so I'm given side A and angle A, and I'm given side B, so I'm going to attempt to find angle B first. So I'm going to, again, I talked about using the form of law of sines where what you're trying to find is in the numerator. It just makes the calculations a little bit easier and quicker. So I've got sine of B1 over side B, which is 2, is equal to the sine of 40 over 3. And in order to solve this one, B1, it's going to be the sine inverse, because we have to undo that sine over there, sine inverse of 2 times sine 40 to sine 40 divided by 3, and we should get about 25.374. So go ahead and pause the video anytime you need to calculate things. 25.374. Okay, so if we scroll back up here to this picture, the angle that I just found is this one over here. Okay, that's my angle B. And I already mentioned that this angle B1 in the first triangle is supplementary to this angle B2 in the other triangle. So once I find the first angle that I can find the matching angle in the second triangle B2 because they're supplementary. So I just subtract 180 minus B1, which is 154.626. So that's going to be the angle B in the second triangle, 154.626 degrees. Alright, and I have A in both triangles, so A and B1 in the first triangle, so I can find C1 because I know the three angles of a triangle add up to 180, so I'm going to subtract 40 plus 25.374 to get 114.626. 114.626. And I can find the third angle in the second triangle, again because the three angles add up to 180. So keep in mind that this 180 here is different than these 180s here. This 180 is because B1 and B2 are supplementary. This 180 is because the three angles of a triangle add up to 180. So I have 180 minus angle A, which is 40, and B2, which is 154.626. Now, some of you may be seeing a problem here, is that I've got more than 180 in these parentheses, and if I plug this into the calculator, I end up with negative 14.626. We can't have a negative angle. Okay, so what this tells us is that there is no second triangle. Okay, so I don't need this, I don't need this, and I don't need this. So if you're working through the problem and you end up with getting that third angle in the second triangle is negative, you know that there really is no third angle. Okay, we still need to find side C1. which you could just call side C at this point if you wanted to, over sine of 114.626, and that's going to be 3 over the sine of 40 using angle A and side A again. So I get that side C1 is about 4.243. 4.243. Alright, there you have it. Again, anytime you have questions, go ahead and pause and write those questions down so you can ask me the next time you see me. Moving on to a two-solution case. So again, a quick sketch of a triangle. I've got A, I've got B, I've got C. This is 6, this is 8, this is 35. Alright, so I see I have another side-side angle case. So I'm going to have A is 35 degrees. There's a possibility of 2 angle B's and 2 angle C's. And then side A is 6, side B is 8. Again, anything that's not given, there's a possibility that there are 2 of them. So side C1 would go with angle C1, and side C2, which would go with angle C2. Alright, so let's go ahead and find angle B1 first. These are the things that I want to find over here. Alright, so I've got sine of B1 over 8 is equal to, and I know A and side A, so I'm going to do sine of 35 over 6. So I get B1 is the sine inverse of 8 sine 35 divided by 6, which is about 49.886 degrees. So I've got 49.886 degrees. Make sure you put your units. And then again, I know that B2 is going to be the supplement of B1. It just happens to be angle B that we're finding first, but if we were able to find angle C, then C1 and C2 would be supplementary. So keep that in mind. So I've got 180 minus B1, which is going to be 130.114 degrees. 130.114. Okay, so B1 and B2 are supplements. I can find the third angles of each triangle. They're going to be 180 minus the sum of the other two angles, so it's 35 plus 49.886, and then this one's 35 plus 130.114. So C1 turns out to be 95.114 degrees. 95.114 degrees, and C2 ends up to be 14.886 degrees. 886 degrees, and then I'm going to use angle C1 to find side C1 and angle C2 to find side C2. So I've got C1 over the sine of 95.114 is equal to 6 over the sine of 35. I always go back to the information that I'm given here because I know it's correct. So I've got C1 is about 10.419, and then I've got C2 over the sine of angle C2, which is 14.886, is equal to, again, 6 over sine 35. The information we're given is the same in both triangles again. So C2 is approximately 2.687. So I've got 2.687 here and 10.419 here. So here's our two triangle case. I'm going to stop the video here. Go ahead and move on to the next video to look at the last two examples, and make sure you ask me any questions.